Hello, and welcome to our session focusing on the role of anxiety and attention on reading outcomes for students with reading difficulties. And as you know, there are three papers that will be presented. One is going to be presented by Philip Capin at the University of Texas at Austin with his colleague Jeremy Mitchek at the University of Houston. And then Greg Roberts is going to present a paper also from the University of Texas. And then, of course, I'm going to be presenting a paper as well, which I'm going to do next. And what these papers have in common is that they are looking at the ways in which anxiety and attention, either as part of an intervention or considering them as moderators, impact students with reading difficulties. So the panel overview is that all of these presentations also include RCTs, and they address for whom and under what conditions these integrated anxiety and attention practices impact outcomes. So my particular presentation is on the effects of a randomized controlled trial comparing three different approaches with third and fifth graders with reading difficulties. Two of the approaches are treatments. One of the approaches is a business as usual, a three-arm study. And in this three-arm study, the aim over a 2-year period was to examine the efficacy of a multi-component reading intervention. So the focus was really on students with reading difficulties in the upper elementary grades. And we randomly assigned students to one of three conditions. Two of the treatment conditions both had the same reading intervention. One of the treatment conditions also interwove within that reading intervention anxiety management practices. The second intervention used the same amount of time that was allocated to anxiety management for math. So that was the way in which the reading amount of time and the amount of interaction with the students was the same. And then a business as usual condition. And just as a means of background, the rationale for our integrating anxiety management is the common childhood mental health issues related to anxiety representing children. Approximately 15 to 20% have some type of anxiety problem. And that increases as students move into the middle grades, with 60% of students having persistent reading difficulties and reporting high levels of anxiety. And what we consider or hypothesize in this study is that there is a bidirectional relationship between reading difficulties and anxiety, such that as students demonstrate reading problems, their anxiety increases, but also those students who have anxiety problems, the sort of cognitive processing associated with those anxiety problems interferes with reading success in a way to have an effect on reading difficulties. The theoretical framework is one that I think you're very familiar with, so I will just mention it, which is the simple view of reading, indicating that what is referred to as decoding or word reading has a multiplicative relationship with language comprehension or linguistic comprehension in such a way that they explain reading comprehension. So just to kind of give you a sense of the timeline and sequence of our events, during year one, which would have been in the fall of 2017, we recruited the cohort of students. We call that cohort one. And that cohort stayed in our study through 2 years of intervention, through third and fourth and fifth, and then we followed the students from fifth and sixth. I won't be presenting the follow-up data today. Just to kind of give you an idea of the participants, in this slide, you can see the number of students, male and female, in each of the conditions by race, home language, and grade. The intervention itself occurred for 80 sessions during the school year, approximately 30 minutes a session. That would be 5 days a week. And it was intended to be supplemental to their core reading instruction, not supplanting it. The group sizes were supposed to be between 3 to 5 students, approximately 4, with the tutors providing the intervention, individuals who were hired, trained, and supervised by our research personnel at the University of Texas. The overview of the intervention components contains these following core components that were integrated. There was word study, fluency with text, stretch text, which was focused on social studies and science, and really aligned with the school's scope and sequence. And we call it stretch text because with teacher support, this text was slightly beyond the students' reading levels. A focus on academic vocabulary, and then for those students in the math condition, there were daily math practice for approximately 5 minutes. Only in the reading plus math group, the reading plus anxiety group had anxiety management practices in addition to those reading components. So the next couple of slides provide an illustration of the practices that were implemented within each of those core intervention areas. So for example, in word study, we focused on automaticity of high frequency words, but as well as multisyllable words and vowel combinations. Since students were in the upper elementary grades, this focus area represented the problem areas many of them had in reading. We also focused on high frequency words using word lists, asking students to acquire the word patterns in these word lists, read these word lists very proficiently and quickly. With these word lists, we were looking for not just accuracy, but fluency, that is speed. In addition to the word reading fluency, we also focused on text fluency. And the intervention examples here focused on the modeling of fluency. So we would have teachers model as well as peers. We had keyword identification. And so with our fluency, we also had a comprehension practice integrated, which was main idea. So using fluency as a mechanism for becoming automatic, but also for considering text and comprehension while you're doing it. And these are just some examples. As I said earlier, our stretch text was designed to provide students with opportunities to read text that is above level, aligned with their content in their classes, but also providing supports for them and if you will, confidence that they can attack and address these more difficult texts. And the idea is that students then, in the classroom, when they see more difficult texts, do not perceive them as unconquerable and therefore they don't read them, but rather as something that they know how to read or can tackle. We also focused on comprehension monitoring. And by comprehension monitoring, we're really trying to get students to enter into that phase in which they use executive functioning to monitor their own sense making, so that they start to ask questions about whether what they're reading makes sense. And if it doesn't, what aspect of what they're reading doesn't make sense, whether it's a word or a phrase. And so you can see here are some examples of the text that we would use. And we would ask students to both look for whether it makes sense and then to identify the word or words that don't make sense when the answer is no. In addition to this, we found it helpful later on for students to learn how to repair or replace the text that doesn't make sense with text that did make sense. We also focused on vocabulary and inferencing. And so, for example, here in this text, what is the meaning of flee as it's used in this text? And teaching students to not just know how to learn words based on teachers providing explicit instruction, but also to learn how to read words, particularly in content areas, by reading around the word to look for clues. And so some of the examples for that, in addition to that, within the reading plus anxiety management treatment, there are also some management practices that integrate how to manage your anxiety within reading. So this is referred to as the Strong Students Toolbox, designed by Amy Grills at Boston University and her colleagues, who was our colleague in doing this work. And here's an example of how you can be a detective and how you can actually think about a thought that you have and its accuracy, how you can be a friend and you can tell a friend some of your thoughts as a way to exercise calming, and how you can be a scientist. Am I sure that that happened? So these strong student toolbox examples provided by Amy Grills are helpful in getting an idea about how we wove anxiety management practices into our reading intervention. And here's another example where students were using a success imagery from an athlete to apply to their own thinking about their challenging tasks. Okay, and so in the treatment that had the same components as the reading plus anxiety on reading, instead of the anxiety management, had math facts. And so here's an example of the kind of math facts or math activities that replaced the anxiety management in the reading and math treatment. In the business as usual condition, we also recorded or explored the school implemented intervention, if there was one, that students participated in who were in the BAU condition. So for the data analysis, the data was modeled using partially nested data. It was nested in Tutor in the 2 treatment conditions. The 3 main contrasts were evaluated. So reading and anxiety versus BAU, reading and math, and reading anxiety versus reading and math. We are reporting on the reading anxiety versus BAU and the reading math versus BAU. The data analysis, the purpose was to evaluate the effect of the treatment and the extent to which time 1 moderated the treatment effects. The contrasts are evident, and then the analysis is portrayed here. The effect sizes for all of the measures are also examined. This table might be a little hard to see if you're just watching this presentation, but perhaps at another time you could look at it a little more closely if you're interested. But to give you the gist of it, if you look at the Gates comprehension score, what you will see is that all of the students assigned to all of the conditions are more than 1 standard deviation behind. And that would be true for most of the measures. So these are students on average who are significantly behind their same age and grade peers. If you look at some of the descriptive data, if you think of the blue line as representing the reading and anxiety group, the orange or red line as representing the reading and math group, and then the darker line as the BAU group. And what you can see here is just the slope of progress using standard scores over time. And for the reading and anxiety and the test of silent reading efficiency for comprehension, these are scores from pre-test in year 1 to post-test in year 2. So this would be over the 2-year period. And here again are the line graphs. Again, the colors remain the same. And this is for the test of silent contextual reading and the test of word reading efficiency, the sight word reading measure. And then here is for a measure that we designed to focus on reading comprehension. The Gates McGinnity has been a challenging comprehension measure for all investigators that are using it in these large scale studies. And this was designed to be sort of a mid-still measure of reading comprehension. For people interested in that measure, here's just a sample of what that measure looks like with the items. Excuse me. And then, of course, we had several anxiety measures. We had a reading anxiety measure that was designed by Amy Grills and our team, and then the Beck anxiety measure, which is used by many research teams studying anxiety. And if you look at the descriptive data here, what we want to see is declining slopes. Unlike for reading achievement, we want anxiety to decline over time. And so if you look at the blue line for reading anxiety and the blue line for the Beck Youth Inventory, that's the line that represents the reading and anxiety treatment condition. If you look at the results from the regression models provided here, this is the red dot is the reading and anxiety, the blue triangle is the reading and anxiety versus math, and then the math versus BAU is the square. And the results from the regression models are represented here. Again, I think you probably can just look for right now at the effect sizes. And what you can see is that while the effect sizes typically favor, for the most part, the reading and anxiety group, the favoring is very small and statistically significant in only a few cases, which I will highlight in the next couple of slides. In terms of the moderation analysis, again, represented on this slide, what we can conclude is that regardless of researcher or school provided treatment, students made progress. So if you look at the slopes, even for standard scores, which controls for age or grade, depending on the measure, the school provided treatment and the researcher provided treatment, students did make progress. And that progress could be interpreted as moving towards closing the gap. The gains compared to previous extensive interventions are pretty similar to those provided in the synthesis that Wanzik and colleagues provide. It may be necessary to provide even more intensive interventions. We do not think that 30 minutes a day is likely to remedy the kinds of linguistic and decoding problems represented by students with very significant reading problems. And these students had very significant reading problems. And more extensive intervention studies like this are needed. If you're interested in this study or any of the work that we do at the Meadows Center, I encourage you to go to the website at www.meadowscenter.org. Thank you so much for coming. And if you have questions, we look forward to hearing them.
Hi, my name is Phil Capin, and I'm a researcher with the Meadows Center for Preventing Educational Risk at UT Austin. And I'm going to report on an RCT that was recently conducted examining the effects of an intervention for English learners with significant reading difficulties in the middle school grades. So this study was conducted with funding from the National Institutes of Health as part of the Texas Center for Learning Disabilities. The Texas Center for Learning Disabilities is led by Dr. Jack Fletcher from the University of Houston. The last presenter, Sharon Vaughn, is the principal investigator for the intervention research team as part of the Texas Center for Learning Disabilities. Included on that team is Jeremy Mishiak and Paul Steinley, who played a big role in the intervention development and testing, as well as Pat Taylor and Greg Roberts, who play a key role in the analyses. So for context, we know that interventions for students in the early grades are associated with more robust effect sizes than interventions for students in the middle grades. A past meta-analysis by Wanzik and colleagues found that the effect sizes range from 0.09 on reading comprehension to 0.20 on word reading outcomes for struggling readers in grades 4 through 9. If we look at L's in that same grade level, there's been fewer studies. Across reading measures, the effect size was moderate at 0.35. But when you looked at just standardized measures, the effect size was near 0. So we know it's difficult to move reading comprehension for struggling readers in the middle school grades, and maybe particularly so with L's, though there's been limited research with L's. So in our study, we were focused on students in grades 6 and 7, and we identified students based on their prior state reading performance. So if they failed the state test in reading in the prior grade, then they were eligible for participation in our study. The second criteria they had to meet was they had to be currently identified as limited English proficient based on their performance on the state English language proficiency exam, or they had to be reclassified in the last 2 years. And in the state of Texas, where the study was conducted, those students are considered in monitoring. The last criteria is that the students had to be identified as Latino, of Mexican or Central American origin. And we included this criteria because the sample for the intervention study served as the same sample that was used to collect epigenetic data. And it was important for the epigenetic study to control for ancestry, given our sample size. It is the case, though, that the predominant population of, the predominant subgroup of L's in our area, in Central Texas and in the Austin area and Houston, are Latinos of Mexican or Central American origin. But there were students that were excluded based on that criteria. So our sample included 358 students, 61% were male, and 97% qualified for free or reduced lunch. And so this study was conducted in several schools that are considered high poverty schools. So it was an RCT. Randomization occurred within school site to treatment or business as usual condition. The treatment involved 2 consecutive years of intervention. So students randomized to treatment were scheduled into a reading intervention period, class, where they received instruction from a research team instructor. Between the 2 years of intervention, students also, treatment students, had the opportunity to participate in a summer book club program. And that summer book club program was self-directed insofar as the students, were provided books and the opportunity to engage online, with the research team. But the instruction was not in person during the summer months. So here's the timeline. So as you can see, in year 1, students were randomized, test administrators blind to study condition, administered pre-test. Treatment students received intervention daily, beginning in that fall, and then they were assessed after 1 year of intervention. In the summer, they participated in the summer reading program. That is, treatment students participated in the summer reading program. And then the following year, treatment students were again placed into intervention periods, 1 period a day. And the only confounding factor here was that in the second year, COVID hit, and so schools were closed. All the participating schools closed in March, and they did not reopen in the spring. So instruction was discontinued at that time. And I'm going to talk a little bit more about this later, but we assessed students remotely for that final time point. Okay, so I'm going to talk a little bit about the key elements of the intervention. In our past research, we've looked at the component reading of skills, namely word reading and linguistic comprehension within the simple view of reading. And we found that, the primary source of reading comprehension difficulties for Ls with known deficits in reading is linguistic comprehension. That accounts for more variance in reading comprehension, particularly, in the middle grades. However, word reading does account for variance in reading comprehension. And the students in this sample and in other samples have word reading deficits. In this sample, I think they're close to 1 standard deviation behind on measures of word reading at pre-test. And so, we did focus our intervention, particularly in that first semester, we focused on word reading. And so we sort of considered the intervention in 2 phases. Phase 1, that first semester, you can see in the graphic, there's a heavy emphasis. The majority of the time is spent on word and text reading, sort of building up those foundational skills. That's not to say we ignored word meaning or text comprehension, but we really tried to prioritize word and text reading development in that first semester. And then over the next 3 semesters in phase 2, we provided, distributed practice related to word and text reading, but our emphasis, shifted to word meaning and text comprehension. The next sort of key instructional element related to the design of our intervention was that instructional lessons were developed in units. And this allowed us to sort of systematically build L's language through content learning. And so units lasted 2 to 3 weeks, and they typically focused on a social studies or science topic. And I think given, what we know about the important role that knowledge plays in reading comprehension, we wanted to make sure that our practices for developing more fluent and more engaged comprehenders, we're simultaneously building students' language and content expertise. And so we did that by, trying to systematically develop students' academic vocabulary and knowledge within units. The next maybe key element of our intervention was that we provided students with frequent opportunities to read and understand stretch text. A common activity within the units was reading these complex grade level texts, typically informational texts, that are beyond the students' reading level and closer to grade level. And we taught text comprehension in the ways that you might expect. We followed explicit instructional routines, providing modeling, guided practice, and independent practice. And we really promoted students to be actively engaged and strategic in their reading comprehension. And one of the primary ways we encourage students to be actively engaged and strategic when they were reading is through embedded self-regulation supports. And so, what did these self-regulation supports look like during reading? It involved setting a goal for reading and identifying strategies before reading the text. You can think of this sort of as a planning phase. And then next, students would read and monitor their strategy use as they read. And then after reading, there was the opportunity for them to self-reflect about what they learned from the text and the strategies that they employed. And then that self-reflection would then inform their goal setting and strategy use for next time. And so this is a sample document that we used for instruction. As you can see, it's organized into a before reading phase initially, where students would identify reading goals and strategies. At the start of the intervention, we set the reading goals for students. And so here you can see we identified 2 reading goals. The first reading goal is to monitor my understanding as I read. And that comprehension-focused reading goal was achieved through 2 strategies. The first strategy being writing main ideas for each section or page. And then the second strategy is to read and reflect when text is difficult. So here you can see that we are providing the goals and the strategies for students, but over time, we shifted that responsibility to students. The second goal is around vocabulary, and it's identifying unknown words and finding their meaning. The strategies that we encourage students to use were to highlight new vocabulary when it appeared in text, and then to find the meaning of the words using context or other resources, and to briefly write down some notes related to the meaning of the word. So that sort of goal setting would occur before reading, and there's reading goals around strategies, and then there's also goals about the content. So there's a question there: what am I interested in learning from this text? During reading, we really want students to focus on the text, and so we encourage them to put this self-monitoring or self-regulation support to the side and to begin reading and to take notes on their strategy use. And the strategies that we encourage them to use were always strategies that were apparent, that we could, for accountability's sake and to maintain engagement, that we could see, that were made visible. And so highlighting unknown words and writing main ideas being 2 instances of that, or 2 examples of that. After reading, they would reflect on their strategy use and discuss what they learned from the text. They would do that individually. And then there would also be the opportunity for a peer conversation where they would have a discussion about the text and a discussion about their strategy use. And so here you can see how self-regulation supports were really embedded as a mechanism for improving students' active engagement with text and strategy use. But it's really not distinct from the reading instruction. It's a part of that. So we discussed some of the key elements of the treatment. You can see sample lessons from this intervention and from other related interventions developed by the Texas Center for Learning Disabilities at tcld.org. Okay, so now we'll get into some of the measures. Here you can see the measures that were administered in year 1. You see 4 primary reading measures. This was a 2-year study, but COVID struck between years 1 and year 2. And so what you'll see is that we did not administer the same measures as we had planned to administer those 4 measures across time points, but that did not occur because when schools closed, we determined that it may be more appropriate to adopt different measures, given that we were going to administer tests remotely. Specifically, we adopted remote testing procedures that allowed us to test students over the phone. And the reason we did it over the phone was because many of the families that participated in the study did not have access to video conferencing technology. And at that point in time, it wasn't safe to be with in person with families. And so all the assessments occurred over the phone. And so you'll see that measures like the letter word recognition and word recognition fluency, we determined we wouldn't be able to administer those validly over the phone. And so we adopted the test of silent word reading fluency and the silent reading fluency from the KTEA. The only measure that we were able to administer across all time points was the Gates reading comprehension test. Okay, so I am going to present some preliminary results. And because the measures vary across time points, I'll try to specify what year we're talking about. So this first measure is a standardized measure of word reading. This is the KTA's letter word recognition subtest. As you can see, there were small non-significant differences between treatment and control at pre-test, favoring treatment. After year 1, you can see there's a little greater effect size between treatment and control. However, this p-value was above 0.05, so it's not considered a significant difference between treatment and control after 1 year of treatment. On the word recognition fluency subtest, you see again a discrepancy between treatment and control at pre-test, which seems to indicate that treatment may have been a little higher on word reading at pre-test. But again, like the last measure, this difference was not significant. After 1 year of treatment, you see that treatment the difference between treatment and control increases just slightly, but again, non-significant. We did see a significant effect on our proximal word reading measure. It's a 45-item word reading measure that primarily assess students' multisyllable word reading. It was proximal in that it was assessing word reading by testing the types of words that were taught. So multisyllable words that followed syllable patterns, and then some what we call rule breaker words. There were not words that we specifically taught in the intervention, but it was aligned to the intervention in that it was focused on multisyllable word reading, which was a big focus of that year 1 instruction. And here you see a significant difference between treatment and control favoring treatment. Okay, if we look at reading comprehension, the Gates reading comprehension subtest, we see that there was no difference in reading comprehension at pre-test. After 1 year, we do see an effect size of 0.1. However, this effect was non-significant. Now, we have our first evaluation here of the effects of the treatment after 2 years. You can see that there is a significant difference between conditions favoring treatment. However, the effect size being 0.38. However, I think this needs to be interpreted with caution for a few reasons. For one, the N is much smaller at that final time point. Despite extensive efforts to get to contact families and schedule them for testing via teleconference, we were able to assess only part of the sample. And so we are currently assessing the role of attrition and then also the validity of the remote assessment procedures. I'll talk a little bit more about that in a minute, but we interpret this with caution right now. We also measured silent reading fluency. Here you can see treatment students scored higher than control students, but this contrast was not statistically significant. On our last measure, our test of silent word reading fluency, treatment did outperform control significantly on that measure, and you can see the effect size is 0.22. So In the spirit of PCRC, we're sharing research that is in progress. I think we're really hesitant to draw conclusions based on these preliminary analyses, but what we can do is we can share some of our plans for future analyses. And so given the high level of attrition that occurred due to COVID, we're going to look closely at attrition and the effects that it may have had on our experiment. In particular, I know that we plan to investigate the extent to which those students who attrited may be different from those students that remained in the study at that final time point. We also plan to assess whether the students that attrited from each condition were similar on pretest performance. We know there were no differences between treatment and control, for instance, on the GMRT reading comprehension subtest at time 1. But is that still the case when you look at students who just remained in the study? I think those are the types of attrition analyses that we are going to conduct going forward. In addition to looking at attrition, we plan to examine the validity of our remote assessment procedures to ensure that that the differences that we see at time 4, are those reflecting differences in students' performance and not measurement invariance. Lastly, we will examine the impact of our reading intervention that embeds attention and self-regulation supports on attention outcomes. So that's sort of the state of this research, and that wraps up my presentation. Greg Roberts is up next.
Hi, presenting today, my topic is statistical moderation. What is it and why should we care? My name is Greg Roberts and I'm at the University of Texas at Austin, the Meadows Center for Preventing Educational Risk. I've several objectives. I'm going to define moderation in general. I'm going to define moderation in the context of experiments, treatment, and BAU types of studies that are randomized. And then I'm going to define moderation in contrast to mediation. There's, I think, still quite a bit of confusion, and rightly so, around those two. And so it may help understand moderation by describing it in contrast to mediation. Then just a little bit about how to model moderation. What does it look like? And then what does it mean when we have moderating effects and also main effects? How then do we sort of make sense of that? And then as an example, I'm going to talk just briefly about a paper that we did last year, 2 years ago now, that's in JLD. And it's a much more sophisticated application of moderation, but I think it does a good job of illustrating some of the points that I hope to make. So moderation in general. So I'd ask you to assume that we have 3 variables. There's a main variable, which we sometimes call the independent variable, the predictor, or maybe just X. A second variable, which is the outcome, which we usually call Y. And then a third variable that for today we'll call M, which you can understand as meaning moderator. This third variable may influence the relationship of X and Y. To the extent that it does, M is said to moderate that relationship. Different values of a moderator are associated with statistically different relationships of X to Y. That's basically the definition of moderation. M moderates the relationship of X to Y. Moderation can be modeled in most types of quantitative data, including cross-sectional, longitudinal, and experimental data. Moderators can be measured as categorical, like gender or ethnicity, or as ordinal, like scores on a 5-point attention scale, for instance, or as continuous, and this would be scores from a standardized measure of reading comprehension, as an example. However measured, moderation involves interaction. Mathematically, moderation involves the product of 2 or more values, and product here is just it's X times M. That is the interaction of 2 variables. It's just multiplying those together and then having a product term for each case or each student in your data set. Interactions of a categorical 2-level moderator, for instance, like gender, in a 2-group randomized trial would yield 4 groups, right? Treated boys, treated girls, untreated boys, and untreated girls. The moderation question would involve contrasting treatment's effect across the 2 levels of gender. So that would be moderation in its most, I think, simple and straightforward form. A 2-level moderator, a 2-level independent variable, you would multiply for each kid his or her values for both, probably either 0 or 1, and you wind up with the 4 groups that you can use for estimating gender's moderating effect on the relationship of X and Y. So you can think about moderation, it represents a way of disentangling data, of making sense of a set of findings that include interaction terms. A statistically significant interaction that indicates that the relationship of X and Y differs at different values of M, or said differently, that X times M, that's the interaction, that product term predicts Y, in addition to, or in a regression, for instance. So I talked earlier about cross-sectional data. Moderation provides a way of talking about interactions within a set of data, but how we talk about these interrelationships, how we talk about moderation depends on the research design that produced the data. In cross-sectional data, as I mentioned, or in longitudinal data, moderation describes the relationships or patterns in the data. By that I mean we can't really talk in causal terms that that the effect of some treatment, that it's the causal relationship of that treatment and its outcome is different. Here we're talking only about interrelationships or associations. In this example, these data are cross-sectional. They describe the SAT scores for test takers of different ages. The data are plotted with age as the independent variable or predictor variable, and with SAT scores as the outcome. The plot does not suggest that SAT scores are caused by age, only that SAT scores vary across ages. Gender is the moderator in this scenario, and the question is, does gender moderate the relationship of age and SAT performance? Individual cases are represented by points on the plot. The best fitting line for the 2 groups, girls and boys, are depicted. The best fitting lines for the 2 groups, boys and girls, are depicted by the blue and green lines. In these data, gender moderates the relationship of age and scores on the SAT. That is, as test takers get older, girls outperform boys. Older girls do better than older boys. Several things to note, though. Notice that the data points begin at about age 17, even though the line of best fit extends downwards to 10 years of age. The same is true on the upward end. It looks like about 50 years is the data point representing the oldest aged participant, even though the line extends all the way to 60. It's helpful to check if estimated values are represented by actual values. In this case, the model included possible ages as low as 10 and as high as 60. Values along the extremes of this range are less reliable than predicted values in the middle of the plot. And I'm going to talk a bit more about that in a moment. Notice as well that the relationships of age and SAT scores modeled as linear. It's not always true that the relationship of X and Y is linear. Other functions may sometimes apply. A quadratic or curvilinear relationship may better describe the relationship it's best to check. Also, this figure helps illustrate the usefulness of plotting values to understand a moderating relationship. In cases where the interaction term differs statistically from 0, that means you've got an interaction. Oftentimes that is not terribly helpful for understanding the nature or how that interaction sort of looks or works. Plotted values can help you untangle this effect. So that might look something like this. Again, you've got the independent, dependent variable. We're assuming this is cross-sectional data. The moderator, whatever that is, it's a 2-level moderator. These are values plotted for let's say boys and girls. And so each plotted value represents 1 kid or 1 case, and the value represents his or her standing on the independent and the dependent variable. You can then plot lines of best fit for those two sets of values or data. And also you can plot or estimate confidence intervals. This is my earlier point. You'll notice that the gray around each line varies in its width. So the band that describes the reliability of that line is wider at the ends of the lines, and that's because there are fewer values of on those extreme ends to support those estimates. So these lines are model based. They're the lines that best describe the patterns in the data, but it doesn't mean that the estimates are comparably reliable wherever you are on that line. Some of these values are better estimated than others simply because there's more data locally to predict those values. Okay, so moderation experimentally, which I think is a primary interest for us who do intervention work. So I'm going to spend a few minutes on this. In cross-sectional data, moderation represents patterns in the data. In experimental data, moderation describes the treatment's effect and the differences in its effect for one or more groups of students. So using the earlier example, assume we developed a SAT preparation program and collected data on its efficacy using a randomized control design. Here, the independent variable is the treatment, or it's really allocation, assignment to one or more treatments. In this case, the SAT prep program or no prep program. The dependent variable in this example is SAT scores, as before. If gender is still our moderator, as it was earlier, the most likely question becomes, is the SAT test program, prep program, SAT test prep program differently effective for boys and girls? However, notice that we can address the same question that we addressed earlier in the cross-sectional data, assuming we collect age data. However, the design under which these data were collected, that is the experimental design, allows for these additional moderation-related questions. And I would think these are more pertinent or more sort of informative questions because they have to do with the effectiveness of treatment. Here, the interaction is treatment and gender, and our statistical models, let's say regression models, would estimate the effect of treatment, the effect of gender, both of which we would call simple main effects. Our model would also estimate the effect of the interaction of treatment and gender, which represents gender's moderating effect on SAT test prep's efficacy. This interaction is a two-way interaction because it involves two factors, treatment and gender. What happened to age? Recall that age was a variable in the earlier example using cross-sectional data. If age data were collected in our experimental study, we can model age as a moderator instead of gender or in addition to gender. Let's say that we used it instead of gender. Age in that situation is a continuous variable, which is different than gender. Gender, recalls, the dichotomous categorical variable. Age is continuous. So the math in this case, the math of doing the moderation would be a bit different. However, it still involves an interaction, which as before is the product of the independent variable and the hypothesized moderator. With gender, again, we only had the four groups, treated and untreated boys and girls. With age, we no longer have groups per se. Each case has its own product or interaction term, right? We still modeled the simple main effects for SAT prep, simple main effects for age, as well as the two-way interaction of treatment and age. Again, this would involve treating age as continuous. So the math is a little different, but the basic concept is the same. And I'll return to this in a bit with the example. We could also estimate the three-way interaction that addresses the question of whether the moderating effect of age on the prep program's effect on SAT scores differ for boys and girls. That's a mouthful. I'm going to say it again. We could estimate a three-way interaction that addresses this question, whether the moderating effect of age on the test prep program's effect on SAT score differs from boys and girls. Basically, you can say that alternatively as whether gender's moderating effect differs for boys, differs for different ages. So we're just interacting now 3 variables, that is treatment, gender, and age. In this case, we would estimate simple main effects for treatment, age, and gender, as well as the 3 two-way interactions. That would be treatment by gender, treatment by age, gender by age, and then the 1 3-way interaction, which is treatment by age, by gender. 3-way interactions can get dicey in terms of interpreting those. So the recommendation generally is only go there if you feel you absolutely have to. And if you think that it represents a question that is of substantive interest to your program of research. So I come back to that example, the 3-way interaction here in a bit. But finally, and as before, and I think regardless of the context, plotting these values, plotting your data gives you an opportunity to get a sense of what an interaction means in the context of your study. So you've either already seen this slide or you're going to see this slide in a bit, but this would be an example of plotted data in a moderation context. Notice the treatment condition, which we normally think of as X, is represented in this case by 2 lines. So X in this case is embedded in the lines. It's not along the X axis. And that's okay. The idea of plotted values is to use them so they functionally, they provide you with a functional tool to make sense of patterns in your data. In this case, it makes more sense to use the lines in the body of the plot to represent treatment conditions rather than plotting those as part of the X axis in the graph. And so this is a good example of taking a fairly complex relationship and using plotted data, making good sense of what's going on. In this case, reading anxiety moderates treatment's effect on students' word reading outcomes. Yeah. So contrasted to mediation quickly, a moderator is usually non-malleable, or if it is malleable, it's not affected by treatment, by the treatment that's being studied. The treatment, in other words, does not change the moderator, either because the moderator can't be changed or because the treatment wasn't developed to change the moderator. A mediator, on the other hand, is tractable. You can change a mediator. In fact, in mediation models, the treatment does have an effect or does change the mediator. And you can even think about mediators as a proximal outcome. So if you have a treatment, again, within a treatment context, if you have a treatment, that treatment's going to change the mediator, and change in that mediator is then going to covary or correspond to changes in the outcome. It looks a little bit like this. At top, you have the moderator, which is going to explain, it represents different levels of effect. So I think we've defined that. The mediator here is, it actually explains the effect per se. In other words, it is going to help describe, or it's going to help define the effect of the independent variable and the dependent variable. And so I think one way, when it's not clear whether you're dealing with a mediator or moderator, one way to clarify that for yourself is to ask, can the treatment or will the treatment change that third variable? If the answer is no, it's probably a moderator, if it's a conditional variable at all. If the answer is yes, potentially, or in fact, yes, it can and will, or did, then you're probably talking about a mediator. And so the figure at top, so now I'm going to move from kind of contrasting moderation to mediation. Now I'm going to talk about how to sort of not analyze the data, but how to think about the data when it's being analyzed. And so the figure at top is just the main effects analysis. This is what all of us do with the first cut of data. The questions concern differences between treated and untreated groups averaged across all students. This second figure shows moderation. This is a two-way interaction, and as outlined earlier, there are three effects: the effect of treatment, the effect of the moderator, and the effect of their interaction. Again, where that interaction is just the multiplicative product or term. It's important to note that treatment's effect in the second model may represent something other than the main effect in the first figure. In this case, the main effect is treatment's effect averaged across levels or values of the moderator. So this is key, and I think this is a point of confusion, even for some of us who do this work all the time. When you add the moderator and the interaction term to the earlier main effects model, and in cases where there's a statistically significant interaction, the question becomes for whom treatment is effective or how treatment's effect differs for subgroups or across values of the moderator. You're still certainly interested in that main effects treatment, but your moderation analysis means that you're really asking a different question. You're asking for whom does treatment work if in fact treatment's effect is moderated. The interaction term in this case drives the model when it's statistically significant, and the main effects for treatment and the moderator are often called simple main effects because they are conditional on that interaction term. In other words, they have to be sort of thought of or interpreted in the context of that interaction. When the interaction is not significant, the moderation model generally defaults to the model for main effects. So if the moderator, or more importantly, if the interaction isn't statistically significant, then really you just have, not you just have, but you are estimating main treatment effects. And this is just for fun here. This is how this would look as an equation. And so you have X1 is, in our case, we'll call that treatment, and X2 would be the moderator, and X1 times X2 is the interaction term, just the product of the two factors, and then B3 is the coefficient for your interaction term. If that's significant, if you have a significant B3 value, this is a two-way interaction, then you have a story to tell. The question then becomes, what is that story and how do I tell it? So for instance, this is an article that we did in 2019 where we looked at class percentage of students with reading difficulties on content knowledge. And we examined the efficacy of a content acquisition and reading comprehension treatment. It was implemented in 8th grade social studies classrooms. We used a within teacher randomized control design so that each teacher was teaching both the treatment and the BAU condition. We had 18 8th grade teachers social studies classes. They were randomly assigned to treatment. For comparison, teachers taught all their classes, as I said, using the same content. However, and this is key, in the content classes, teachers used instructional practices focused on knowledge acquisition, and they used team-based learning principles. And that, I think, is a key point that I'm going to come back to. Students with reading comprehension difficulties in the treatment classes, there were 359 of those students, outperformed students with reading comprehension difficulties in the comparison classes on measures of content knowledge acquisition. In addition, the proportion of students with reading comprehension difficulties in classes moderated outcomes for content knowledge acquisition. Notice that last sentence introduces a fourth variable and a second moderator, and this would be a class level moderator, which is the percent of kids, proportion of kids who are struggling in that class, where we're estimating the effect for a single struggling student. So we have four variables. We have treatment, we have the outcome, we have whether or not an individual kid is a struggling reader, and then we have at the class level the proportion of students that are struggling. So this represents really a three-way interaction, where interactions across levels of the multi-level model. We have student and classroom effects. In the above figure, or the figure you see here, the simple main effects are highlighted in yellow. the two-way effects are in green, and the three-way effect is in blue. Because the three-way effect is statistically significant, we interpret the main effects in the context of the three two-way effects and in terms of this higher order interaction. Okay, so because blue is significant, green and yellow become sort of conditional on that. We have to think about those results in the context of that higher order term. Now, the coefficient here is negative 0.72, which differs from zero by quite a lot, but doesn't really tell us a whole lot, right? And so again, as before, what I would propose, what most would propose, is that you plot those values. And we did that. And so here we have 4 lines, each representing a group of students struggling and condition across. That is struggling students and the condition that they're assigned to treatment or comparison across. The X in this case is class percentage of struggling readers as on the graph. As before, we're plotting data in a way that makes it most interpretable. X here is not the independent variable as it was in the cross-sectional case, because we did not manipulate class percent struggling. Also, the x-axis does not represent time points, even though oftentimes we sort of think of this as being a linear or time related relationship, but that's not true in this case. In this case, the x-axis is different values of the class percent of struggling readers. And we had classrooms with as few as 10% of struggling readers, and we had classrooms with as many as 90% of struggling readers. The takeaway from this is that students who are struggling to read benefit from treatment in 8th grade social studies classes compared to struggling readers in BAU. However, and this is the key however, the effect diminishes as the classroom percentage of strugglers increases. Recall that I said that in the PACT intervention, which it relies on peer supports or a team-based learning model, a preponderance of struggling readers in a classroom diminishes treatment's effect, all else being equal, because this individual struggling reader has less, let's say, less capable supports. His or her team is going to be lower on average as readers, and it seems that is not supportive of individual students improving their reading comprehension in a content area classroom. In classrooms with large proportions of struggling readers, the outcomes for struggling readers in treatment do not differ from the outcomes for students in BAU. So if you look at the 80, 70, 80, 90% classrooms like that, the outcomes for students who are struggling are really not different from kids in BAU. Classrooms where most kids, or at least a majority of kids, are not struggling, they're what we might call typicals, struggling readers do really pretty well. They certainly outperform control struggling. They even outperform non-struggling students in the BAU, which is, I think, a notable finding. So bottom line, what is moderation and why do we care? I think moderation can help disentangle main effects. It's a way of understanding how treatment's effect may differ for students or for subgroups of students. Oftentimes we include moderators in papers or proposals for funding because that is the expectation. However, moderators should only be considered if you have a theory or a research-based reason for including them. If your primary purpose is treatment's main effect, modeling moderation may be counterproductive. That's not to say that you wouldn't then go on to look at moderating effects in subsequent analyses, but moderation, in our opinion, in my opinion anyway, isn't the place to start, not in treatment-based or intervention research. By strategic here, the last point, what I mean is that your selection of moderators should support your overall program of research. Knowing that an effect differs for some students but not others may be important from a scientific perspective. However, if your aim is program development or treatment intervention development, And if the moderator is truly non-malleable, it may be enough to know that the program is effective on average for the population of students in question. On the other hand, if your moderator is malleable, but not necessarily an outcome of your treatment, say word reading fluency when the treatment focuses on comprehension, demonstrating that treatment effects differ depending on levels of word reading fluency at pretest would be an important thing to know. A word reading intervention may benefit low word readers before participating in a focused reading comprehension intervention, in which case that would be an important caveat, and I think would inform your program of research. Note, however, that a few simple changes in that scenario makes word reading a mediator, not a moderator. For example, and I'm going to end on this, and it is, well, I'm going to end on this. So, for example, if the intervention is a multi-component treatment rather than just a reading comprehension treatment, and if it addresses word reading and comprehension, it might be reasonable to expect improved word reading as a proximal outcome, right? Because you're teaching word reading, because word reading is malleable. And then you also might expect improved reading comprehension to result from improvements in word reading. That would be a more distal outcome. Word reading would be more proximal. And to the extent that they are temporally, in terms of time, can be sequenced in that way, it would make sense that in that context, word reading would be a mediator. So the point there is just that word reading would mediate the effect of multi-component treatment on reading comprehension in that context. And so mediation, moderation, it's entirely possible for the same variable to be either, not always, but in some cases could be either. And the way you model it depends on the program, the design in which you're modeling or collecting the data for your program of research. And so the recommendation here is to be strategic when selecting moderators and to examine moderation only in cases where it will inform your program of research. So that, I think, is enough said on that. I hope it's helpful, and best of luck to all. Thanks.